Number 16. This one takes up like the whole page if you're looking at the paper version of this test, the digital version. The graph, actually I'm going to zoom in because let's make it so you can actually read it. How about that? The graph of the rational function f is shown where y equals f of x and x is greater than or equal to 0. Which of the following is the graph of f of x plus 5 where x is greater than or equal to 0? Okay. This type of problem where they're taking a function and they are translating it, they're moving it around the xy plane, very, 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 very common on the SAT. They love it. Right, so I always like to go through the basic rules when one of these problems shows up because I think these rules are worth learning. Just, it happens all the time, and if you can learn these rules, man, it's going to save you so much time so that you're not trying to plug things into Desmos to figure these out. They're a lot quicker if you know these rules. Okay, so here's the basic, and this is going to apply, to all of our functions. So like, let's say if I had y equals x squared, we can also call this, I'm going to, f of x equals x squared, right? That's what it looks like, essentially. It's just a parabola. It has a vertex at 0, 0, and that's it. What would happen if I said plus 2 on the outside? If you were adding something outside of that core original function, it's going to move it up or down on the y-axis, and it's going to move it directly. So if it says plus 2, it's going to move it up 2, and you're going to end up with the same parabola, just up 2. Okay, what if that change happened inside of this core function and it was plus 2 in here? Well, if it's inside it, like inside those parentheses, it's going to move it left or right on the x-axis, but it's going to move it in the opposite of what you're seeing. So plus 2, it's going to move it towards the negative 2 on the x-axis. So it moves it that way. The other common things that you see, the moving up and down is what they love the most inside the SAT. But the other common things that you will see is, let's say if you have the x squared and you put a negative in front of it, that flips it upside down. And then the other one you'll see, the last one you'll see for these kind of problems is if there is a number in front of it. They put a number in front of it. If that number is greater than 1, it's going to make this, I messed up my pattern. Green, there we go. If it's greater than 1, it's going to make it narrower. It's going to compress it laterally. And if it is a positive number but less than 1, so a fraction, like say 1/2, that's going to make it wider. It's going to stretch it. Now all of these can be combined, and they like doing that as well. So if I had this original x squared, and let's say I added on a -1, a plus 2, and a negative out front. Okay, so the vertex is going to move it. This -1 is going to move it to the right 1. It's going to move it positive 1 on the x. And this plus 2 is going to move it directly. It's going to move it plus 2 up. So my new vertex is going to be right there. And I don't have a number out front, so it doesn't get wider or narrower, but I do have a negative, so it's going to flip it. And it's going to look kind of sort of something like that. So these rules, these basic rules, it's worth practicing these. It's worth remembering them. It comes up all the time. So here you say, well, this looks a little bit different because it's not that we had, like x squared and then we added 5. It was y equals f of x, and then it's y equals f of x plus 5. Well, since y equals f of x, so whatever this is, whatever this thing is the whole function, we can treat it the same way because it's the whole function and then 5 is being added on the outside. Remember I said when we had that whole function in the example of x squared and then 5 is added on the outside, it's the same. So if I just said x squared plus 5, or I said f of x, and I already told you that f of x is x squared plus 5, it's the same thing. I'm hoping I explained that correctly and in a way that's easy to understand. But because it's a unit, this whole thing is a unit, and so that plus 5 is being added on the outside. And so here you have that f of x is the whole unit, and the plus 5 is being added on the outside. So it is outside of the function, and we can treat it as it's moving it up and down on the y-axis. Okay, so how can I tell which of these is that top one moved up or down on the y-axis? Now you might look at it and go, well, clearly this one is moving up. Oh, this one looks like it's moved down. This one really looks like it's moved down. This one just looks a little flatter than that one, or didn't really changed a little bit, but not a lot. This one clearly looks like it's moving up and down. And, you know, frankly, you are right. That is our answer right there. It has moved up. But for your future reference, the way you do this to be sure, like if it's not perfectly clear, you're going to pick a test point. A point that is visible on here and looks like it's going through a point of intersection. So I might go for that one right there. And actually I'm going to go boom and boom. There's my 2 test points that look pretty clearly like they're going through a point of intersection. So the first one there would be this. I have picked a wrong. Let's make this a little smaller so you can actually see this. Hey, there we go. That first one is 3, 3. And that second point is 9, 1. So if this point 3, 3 was to go up by 5, that x is going to stay the same. X doesn't change. The y value will go up by 5. So I would expect it to go up to 3, 8. 3 plus 5 being 8. Same with this other one, 9 and 1. That 9 is not going to change, but the 1, that y value will go up by 5. So 9, 6. And then you're going to look for one of these points. And if you find 2 graphs that have one of those points, then you look for the other point. Okay, so here's my first one, 3, 8 and 9, 6. Not even close. There's 3, 8 and there's 9, 6. Nope. My second one, there's 3, 8 and there's 9, 6. Not a chance. My third one, there's 3, 8 and there is 9, 6. And my last one, there is 3, 8 and doesn't like when I draw dots. Never does. Okay, there we go. And there is 9, 6. So yes, that is confirming that it's D. Again, with something like this where like your choices A, B, and C are clearly not moving up, and we know it needs to move up, you don't necessarily have to go through this process. This is a way of confirming it if you are unsure, or if you have a couple of graphs that look similar. Again, I'm giving you techniques that will help you not just for this problem, but for any problems that you may have that are using these similar topics. Okay, so again, our answer for that one is D because it moved up 5. Hey guys, just a quick heads up. I've got some cool stuff coming for y'all, including a free course full of SAT tips and tricks, as well as an exhaustively complete course on everything you need to know for the SAT, both math and reading. So subscribe to the channel to get notified when that goes live. I'm also going to put it in the comments and description below as soon as it does. In the meantime, if this video was helpful or useful in any way, please let YouTube know. Comment, like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.